All right, you've learned all the methods of factoring, so you're going to get a bunch of problems and they're all going to be mixed up. And the most difficult part, I think, of this is figuring out which method you need to use to factor. So how do you decide? Really, you need to just consider the number of terms of the expression that you're going to factor, and that's a good starting point. So if there are two terms, you first need to ask yourself, is there a GCF? And if there is, factor that out first. And then could be difference of squares, because we know that difference of squares has only two terms. So if that's the case, then you're going to factor that in the a plus b, a minus b model. Okay, if there are three terms, first thing you do is ask yourself, is there a GCF? If there is, factor it out. And then you need to see, is it a trinomial set up in the x squared x constant format? If that's true, then you can either use the sort of guess and check method, or you can use the AC method to factor that trinomial. And that comes out ending up being two binomials, usually x plus something else in that general format. All right, if it has four terms, first ask yourself, is there a GCF? If there is, factor it out. Then you ask yourself, hey, is this grouping? And most often the expressions with four terms end up being grouping. That's a little bit contrived, and so often that's what is the case with the four terms. If it has five or more terms, ask yourself if there's a GCF. If there is, factor it out, and there's no other method that we know of. So if it had five or more terms, it would just be a greatest common factor problem. All right, let's try some. 5x squared minus 45, you're going to ask yourself what's going on here. Two terms. So is there a GCF? There is. 5 is common to both, so we're going to first factor out 5. And now we're left with two factors. So we have to look at what's left over, x squared minus 9, as one of the factors and say, could I factor that? Am I totally done? And so I think to myself, what is that? Well, that's also two terms. So there's no GCF because I've already factored it out. Is that difference of perfect squares? And it is. So we can go ahead and factor that portion of it into x plus 3, x minus 3, including that original factor of 5. 2x squared minus 30. Again, what do we have here? Again, it's two terms. So is there a GCF? There is. I'm going to factor out a 2. I'm left with x squared minus 15. Now I ask myself, that leftover part, of those factors, are they totally factored themselves? And so I look at x squared minus 15 and I say, two terms, is that difference of squares? It's not, because 15 is not a perfect square, so we're finished. All right, x squared plus 100. Same thing. What do we have? Two terms. Is there a GCF? No greatest common factor here, so that's not a possibility. Is it a difference of perfect squares? It is not, because it's not difference, it is adding. So this one is prime, no factoring possible. All right, the next one, there's our little table. What do we have here? Three terms. So is there a GCF? There is not. Is it a trinomial in that format that we're looking for, x squared, x constant? It is. So this is one that has a leading coefficient of 1, so I know that I can just do it in my head, sort of with that guess and check method, what multiplies to 9 and adds to negative 6, and I see it's minus 3 and minus 3, and so we have x minus 3 times x minus 3 that you know you need to finish up and write x minus 3 squared as your final answer on that one. All right, next one. What do we have here? Three terms. All right, so I say, is there a GCF? There is. 5 is common to each one, so I'm going to factor out the 5. And then I look at my remaining factors and say, hey, any of those factorable? And I see that factor of x squared minus x minus 6. That also has three terms. So I think, is that a trinomial? It is a trinomial in that format that we want, x squared x constant. It is. So I'm going to factor that into x plus 2, x minus 3. Here's another one. What do we have here? You can see there are four terms. So is there a GCF? I'm going to look at all those. What do I have? I've got the coefficients, no common factor to all four. There's an A in a few of them, but not in the rest. There's an X in a few. There's a Y. There's a B, but there's nothing common to all four. So there is no greatest common factor to all 4 terms. So now I'm going to look and say, okay, can I do it by grouping? So pretty much you just need to try grouping and see if it works to see if it's factorable that way. So I'm going to go ahead and do my grouping method, and we come out with 3a plus b times x plus 2y. All right, here's another one. How many terms here? 4 terms. Is there a greatest common factor? You can see that there is. There's a 2 common to every single term, so I'm going to factor out a 2. So then I'm left over with a factor that's an expression that has 4 terms. I need to see if I can factor that. So again, 4 terms, I got to try grouping. So I'm going to give that a shot. You can see by doing the grouping method, it does factor by grouping. Don't forget to include that factor of 2 along with your factors of 3y minus 7 and 4x plus 1. All right, now we're going to think about this in a second way. What if somebody looked at that and said, hey, 4 terms, and they went right away to grouping? So we could actually factor it by grouping. But now what's important is when you finish factoring by grouping, get an answer. It looks great. However, you need to really pay attention to your 2 factors that you've got right there to see if either of them could be factored more. And you can see that 8x plus 2 has a common factor. Okay, there's a GCF in there, so this is not completely factored. So we need to factor 8x plus 2, factoring out the greatest common factor of 2. So you can see I've factored it out. I like to list the monomial factors first, so I've written that first, and so you can see 8x plus 2 factors to 2 times 4x plus 1, and then we have the 3y minus 7 there as well, so you can see our 2 answers ended up being the same. We did 2 methods of factoring, grouping and GCF, and we did them in 2 different orders, but we came up with the same result.